Alright guys, my name is Sergey. How's it going? Hope you're doing well. And today I'm gonna talk to you about design pattern, which is pretty common and very important in my opinion topic, which every seasoned programmer should know about, at least the basics. And I think that one day I might make a video about overall overview of all design patterns in general, but today since I'm short of time, to be honest, today I'm gonna discuss one pattern which is called factory method design pattern, which is the um, creational design pattern. And I think that we can make a quick overview of this design pattern. We can jump into our terminal and write some code. Hopefully you enjoy it, and let's get started. So this so Alright guys, sorry for delay. This picture I found on the internet. There's pretty much a whole bunch of such similar pictures all over the place, and basically what factory method design pattern means. It can be broken down, in my opinion, in four main parts, such as two which could be considered as abstract classes, and the other two will be actual implementation of those abstract classes. Hopefully it makes sense. So the first one can be a product, for example. It doesn't mean what kind of product we're talking about. It could be a geometrical figure, a person, a car, pretty much any object you can think of. And the creator class, in our case it will be class, is an abstract class which is going to represent a blueprint for concrete creator of a concrete product, a concrete pattern which is gonna be extended from this abstract class. And we're gonna use the C++ programming language, and with pure virtual functions when designing abstract classes, because it's kind of a way to implement to invoke abstract classes, to design abstract classes in C++. I think that it would be a good practice for you guys, and even if you are not familiar with C++, I think that you might find this video entertaining, because it has to do with object-oriented programming, inheritance, and abstract classes, as already pointed out, and things like that. Hopefully you enjoy it, and let's get started. Here I created a file. Actually I'm using the Vim editor. You can use whatever editor of your choice you prefer, doesn't matter really, but for this small little video I'm gonna use Vim editor. It's lightweight, it's fast, and it works on Linux, since I'm on Linux Ubuntu. Alright, so let's scaffold out our strategy a little bit. We're gonna say implementing factory method design pattern in C++. Alright, using object-oriented paradigm, as already mentioned before. Here's our strategy. So I'm gonna try to do it as quickly as possible, and I'm gonna comment my code heavily, just in case, guys. Maybe some of you will be willing to have a look at it in the future, if you wish, of course. Alright, first of all, we need to create an abstract product class with your virtual functions, right? Next, we need to create kind of an actual implementation of that class, and when we're extending a class from an abstract class, we must we must implement all of the functions which were designed in the parent class. All right, that's the principle of object-oriented programming in general. Next, we need to create a factory creator, an abstract creator class with pure virtual functions as well. And finally, we need to create an actual implementation of the creator class. Okay, so that's our little strategy. First of all, we need to include a couple of directives, stream to work with input output. Need to include, and you should have a basic understanding of pointers and dynamic memory allocation in C++. But if you don't, it's not, it's not the end of the world, because I'll do my best to explain everything. All right, include memory for working with dynamic memory allocation and stuff like that. Yeah, first of all, abstract class, creating abstract product class. All right, and for the sake of this example, I'm gonna use the example of geometrical figures such as square and circle, for instance. It doesn't matter what kind of classes you're using, but I'm gonna use geometrical figures. Let's design an abstract shape class, and here we're gonna define our public member functions, which are basically methods, okay, in any programming language, in other programming language such as Java, JavaScript, and Python, for instance. But here in C++, we call them member functions and member variables. All right, public member functions. All right, and we're gonna say virtual, since it's an abstract class, and these functions which were defined here, they will be overridden in the child class. All right, a virtual void, it doesn't return anything. We just it's gonna be pure virtual function. All right, it should be overridden, implemented. Okay, in the extended class, we're gonna use virtual destructor for for dynamic polymorphism, stuff like that. Virtual destructor. All right, and that's basically it for our class. Next, we need to define an actual shape. Okay, class. We're gonna define a couple of them. First of all, we need to we'll define circle, for instance, class public member functions. We don't need a constructor. We need to override our draw member functions, which was designed over here in the parent class. Draw, gonna say draw override, okay, and we're gonna say stdc out, just join circle constants, and I'm gonna end the new line. So right, so seems like we'll have a little mistake. Alright, so I mean, sorry guys, I didn't mark our yeah, my bad. Yes, we didn't mark our class as an extended class. We need to use public inheritance here. Alright, like this. Okay, so that should do it, I believe. Yep. Next, I need to define other, design another square, for example, class, which is gonna inherit from a shape class, the abstract class. Public member functions. I'm gonna say public avoid draw over, need to override the parent member function. Okay. Alright. Join square. Okay. Gonna end our line here. And yeah, I think that should do it. Next, we need to create abstract factory kind of method class, you can say so, for creating actual objects like circle and square. Alright, so we need to save shape factory like this. Public member functions, go here, okay, to say public. So we're gonna create a virtual function which is gonna be type of pointer to the shape class. Okay, since we're gonna use dynamic member allocation, shape, create shape, I believe you can say shape. Okay, then we only equal to 0 pure virtual function. All right, which must be implemented in the, let's save our changes. Let's center our terminal a little bit. Okay. Alright, so we need to define our virtual destructor here for virtual polymorphism. Okay, just so that our destructors will be our classes will be destroyed one by one, in particular order, if we can say so. All right, because otherwise we're gonna receive some warnings in the console. Okay, when we start compiling our program. All right, so virtual destructor. Okay, that should do it, I believe. Virtual, so about guys, my bad. Virtual, like this. Yep. Alright, so next we need to find actual factory method kind of class. Okay, we're gonna say class circle factory for creating our circle object. Public public number of functions. Right. Public, let's say virtual shape, create shape. We need to override standard behavior of our pure virtual function defined in the parent class, okay, since it's the abstract class, okay, which can be instantiated on its own, which should be extended. Sorry guys. Alright, we're gonna say return new circle. We're gonna dynamically allocate memory on the heap for a new circle object, okay, and that's what this factory method pattern is about. And let's create another class which we will call square factory, okay, public member functions go here. We're gonna say public virtual shape, which is gonna be pointer to our shape plus, okay, type of pointer, right? Return new square, okay, like this, and that's pretty much the implementation, okay. Our classes, seems like I have a mistake. Mark override doesn't override any functions. First of all, we're going to need to mark them as virtual because they are virtual by default, okay, here as well. Alright, so guys, 1 second, I'm gonna figure out if it can work. Override. Yeah, my bad guys, sorry, but I forgot to extend shape factor, of course, stupid me. Sorry guys, my bad. So yeah, just I need to, to get back to the track, so to speak, because I've been lately a little bit busy and I haven't been working on my C++ skills, so to speak. Yeah, sorry guys, didn't mean to offend anybody. I know I really appreciate your time, precious time, your attention, things like that. Implementation. Let's write our implementation. I'm gonna say int main avoid return 0, scaffold out our main function, and I think that we can center a little bit our terminal. Yep, I think that we need to create a couple of variables like shape, for instance. Okay, and we're gonna have a user input. I'm gonna say enter a shape like circle or square, for example, right? And I think that we should use the lower function in C++, so that if user enters types all capital letters or all lower letters, they will be interpreted by a compiler like lowercase letters, for example. Okay, that's important. And I would say I'm gonna do it in a for loop, I believe. For auto C, I'm gonna pass it by a reference, because since we're gonna modify the original string shape. Okay, hope that makes sense. In shape, we're gonna say C equals to std not out, sorry, but to lower C, I believe. Yep, that should do it. So now we're gonna say if shape is gonna be equal to circle, for instance, then we're gonna say we need to instantiate the circle factor. Okay, we need to say shape factory, like circle factory of new circle factory, like this. Okay, else if that's not the case, else if shape, we can use switch here, but it's not convenient because I believe in C++ we should use numbers instead of strings in switch. When dealing with switch operators, that's not very convenient, to be honest. That's why we use if statement. That's okay. That's fine, I believe. Shape equal to square, right? Like this. Sorry, guys. Oops. We're gonna say shape factory square factor new square factor dynamically allocated memory. Okay, on the heap for a new object. So this base. So guys, just one sec. I need to debug a little bit my program. Square factory. Sorry. So I see my mistake, and it's because I inherited when we don't use a specifier in our inheritance. We kind of by default we inherit privately, and that's why we can't use instantiate our object from the privately inherited class. Hopefully that makes sense, guys. Yep, that should fix it. Yeah, and now no, I think that we can shape factory like this. Shape factory. Yeah, we can use this one pointer, which is gonna point to only one memory location at a time. All right, and then need to use any other. Yeah, and now we can here we can instantiate. We can say so, guys. We can say shape factory. Shape factory. Factory. Shape factory is gonna be equal to null pointer by default to get started with, alright? And otherwise it's gonna be equal to no, we just need to see out run shape. Okay, std online, that's it. And we need to return -1. Yep. That kind of means that everything is went wrong, alright? And we should terminate our application. So next we need to kind of create our class, our shapes. Okay, so we're gonna say shape factory just let's see shape is gonna be equal to shape factory, I believe, create shape. Okay, it's gonna be pointer to this shape class. All right, because it's returning a new shape object, which is gonna be pointer to this abstract class. Abstract class. All right. Yeah, that should be alright. Hopefully that makes sense, guys, and it's not very difficult to comprehend. Alright, and we're gonna say shape, finally shape, draw. Yeah. And it's gonna invoke our method, whether it's circle or square, alright, depending on whether it's a circle or a square object. Okay, hopefully that makes sense, guys. And finally, after we're done, we need to return memory back to the operating system after the object has been destroyed. Okay, destroyed. Oh, so guys, remember the draw. Sorry guys, it's naming conflict resolution. Yeah, shape, my shape. Let's call it my. Sorry guys, my bad. My shape. Let's call it my shape. Since we already have had shape variable over here, alright? Yep. Stupid me. Yeah. Yeah, that should do it. So for that we should return memory back to the operating system, alright? We need to say delete shape pointer, right? Shape factory. Delete my shape pointer. Okay, and that should do it. So now we need to test out our little application by saying g++ -g because we wanna be able to go to the debug mode. We're gonna see all warnings. We're gonna treat all warnings as errors. We're gonna use std C++23 as the modern, the latest version of C++ as far as I'm concerned. And we're gonna say, so what are we gonna say? Just 1 second. Yeah, factory method. Alright. So we're gonna say g++ -g all warnings as errors. std equals C++23 factory C++ cpp -o prog. Up. So unused variable shape factory. Yeah. Seems like we have an unused variable shape alright. Shape factory. Shape factory. I think that so just can comment about that. one more time. Use variable shape factory 74. Yeah, I see. First of all, we need to don't need to use it to delete it. Alright. Yeah, sorry about that, guys. We need to scene, of course, scene shape like this. Let's compile it one more time. So let's ignore all those warnings for now. And let's run it with Valgrind, which is a tool to to check memory leaks, which is a great tool, by the way, which every programmer should know, in my opinion, especially when working with dynamic memory allocation and low-level programming. All right. Valgrind. Oh yeah. All right. So let's square. So drawing a square. Here we can say that we're drawing a square, and so our factory methods are working correctly. All right. Drawing a square. Yeah. Let's say that we wanna recompile it. Sorry guys. Run it one more time with Valgrind, and as you can see, we don't have any memory leaks here, because we, after allocating the memory on the heap, okay, or here, okay, here, we successfully deleted it over here. We return it back to the operating system. That's why we don't have any memory leaks, which is can be pretty dangerous if you're working with on large projects, because you might face an issue when you will run out of memory, and it's gonna crash your program, of course. Now let's say circle, try a circle. All right, seems like our little program is working correctly, and yeah, I think that we can stop here. Thank you for watching, guys. So for for this video to be very long, I haven't been programming for a while, as already pointed out, and I apologize for for wasting your time. Maybe for somebody it was a waste of time, but hopefully it wasn't, and you learned something new, something useful, and yeah, guys, thank you very much for your attention, for your time, and yeah, take care. All the best.